So, in one video, we covered all the different types of arteries, and in another video, we covered all the capillaries and we talked about a capillary bed and how that kind of stuff works. And now, what we're going to do is we're going to turn to the next structure in line, which is the veins. So, remember that veins, their role is to bring blood from the capillary beds back to the heart. And the veins are rather unglamorous because most of the work that we think about being done in the body is done at the level of the arteries. The arteries decide where blood is going to go, and they are able to constrict blood flow from one area, and they're able to control blood pressure, and they're able to control body temperature. So the veins aren't really thought of that much, but in fact, their role is very tricky and very important. So if the role of the vein is to return blood back to the heart, remember that that is actually quite challenging for them. One of the things that structurally you will notice about a vein is that the tunica media is very undefined. It does not have a well-defined tunica media. Remember this? These kind of floppy things with these big old lumens in there. So they do have three tunics, but they tend to look much thinner, like the tunics themselves look much thinner than the arteries that are paired with them. The tunica media is very poorly developed, very thin. The tunica externa can be quite thick just to allow for some level of structure to take place in the vein. But yeah, the tunica media is a point of contention for veins because the idea is that arteries are able to control where blood goes, and they're able to squeeze and able to put pressure on the blood. Veins have none of that ability, so they're very challenged. Think about where veins are. Think about the fact that veins must return blood sometimes from extremities that are quite far from the heart, from the tips of the fingers, tips of the toes, all the way up these very long legs and these arms, and oftentimes against gravity. Like if you think about a person standing all day at their job or something like that, then the veins have even more of a challenge, and they don't have any musculature to do it. So let's talk about the special aspects of veins. They're able to accommodate a large blood volume. 65% of the blood in the body tends to be in the veins, although if you look at different texts, they'll tell you different things, but somewhere around 65% of the blood in the body at any given time is found in the veins, and therefore the veins are called the blood reservoirs. Another special aspect of veins is that blood is not pumped. Blood is not pumped through, like, where the arteries are able to contract and allow for blood to be very different, very specifically run in one specific direction. Veins do not have a good tunica media. They do not have good musculature, and so they cannot do that. So they do not pump blood. Instead, they milk blood, and blood tends to be milked through muscles. So if it is a vein what's what we call a deep vein, the vein will go up through the muscles of the body, and when those muscles contract, they help to milk the blood upward or in one direction through the veins. And what keeps it going in one direction are these other structures that are very special about veins that are called venous valves. So here's a venous valve that is closed, and here's a venous valve that is open. And just so you know, these act quite a lot like the semilunar valves in the heart. So we have the aortic semilunar valve and the pulmonary semilunar valve. And remember that they are just these cups that kind of flap open when blood is going through. And then when blood falls backward into them, the blood gathers in the cups and they naturally fold back together. So it's a really passive structure. It's a really important structure, but it does not have a musculature to it, and there's no purposeful movement of it. It just kind of works passively to enable blood to only move in one direction. So the valves are meant to prevent that backflow towards the extremities of the body, and these are especially important, of course, in the legs. And also in the arms, but probably most important in the legs because of the secondary effect of gravity. Not only do you have legs that are very long, but also the gravity kind of working against the flow of blood upward through the leg. All right, there are three different types of veins, just as there are three types of capillaries and three types of arteries. There's a lot of threes in this chapter. So the three types of veins are, we have venules. So what we call post-capillary venules are the venules that are closest to the capillary bed, post-capillary venule. And these are the smallest of them. What they are is basically an endothelium with some pericytes. Pericytes are little structures that allow for a little bit of structure to be present. So when we look at this, when we look at the capillary bed that we looked at earlier, if you look closely at that postcapillary venule, you'll tend to have these little structures called pericytes, which are smooth muscle fibers, which surround the venule and give it a little bit of extra structure. Postcapillary venules are very porous. Fluids and white blood cells can move very easily through the walls of the postcapillary venules, and they tend to be quite vulnerable because of that. So you have a lot of things that are kind of coming into the venules at the level of tissues. So at the capillaries, there's a lot of things entering into the blood, but still at the postcapillary venule, some things that are present in the tissue still are able to enter into the blood, into the circulatory system in that way. The larger venules will not just have, the endothelium and the pericytes, but will also have some other structures like some smooth muscle layers and a very thin tunica externa, for example. Okay, so that's the venules, and then after that point you will have the named veins, which would be named after the structures, organs, tissues, or body regions from which they are draining blood. So for example, the renal vein drains blood directly from the artery. The brachial vein would be draining blood from the region of the upper arm, just as examples. And then lastly, you have the vena cavae themselves, the superior and inferior vena cavae, which are quite large and very close to the heart.